Alright, this is part 2 of building a Boomgate system. Give me 1 second while I get set up. Okay. Alright, so recap. Last time we were here, we connected a ESP32 CAM module to our breadboard. We gave it power and we connected a servo motor, which is going to act as our boom gate. And what we're going to do next is get the camera on here going. And once we have the camera going, we can hook that to some sort of license plate detection system and have it detect the license plate and hopefully do something with it. Okay, so I don't think I'm fully set up yet. We probably don't need this information just yet. I do need power though. I need USB-C. Why is it never the cables you need that are available? Okay, I got a USB-C cable, but I don't have a power supply. Yeah, this will work. This will work. Okay, so we have a power cable. USB. No, we don't need USB-C, do we? We need USB something else. USB, I don't know, what do we call that? Mini? I think it's mini. Oh no, it was C. I need to pay more attention. Alright. So USB-C goes into here. That gives us power. And then this little guy will, the last thing we programmed was a sweep, so it's just going to go backwards and forwards. So I'm just going to let that sit and move around. It's not Subway Surfers, but I'm sure it'll do the same thing. Okay, so what do we want to do? We want to find a permanent marker. We have an ESP32, where are you? CAM. So we have let's write that down, ESP32 CAM. And what we want to do is from that device, we want to take a photo. We'll go into more detail into how we want it to do that. And then we want to send it to a server. So we'll say send to server. And the purpose of that is for us to get well, let's break down what that server is. That is an ALPR web server. And what we want to get back is a detection. So what we want it to do is take a look at the photo, find out where the license plate is, crop that image and send it through some sort of OCR, and we'll get back a license plate. So what we want back is an ALPR detection. And then for now, I'm not sure what we're going to do with it. I think we will put a light web server on here. And somehow display this result. And display result. Okay. So, all right, let's work out how we're going to take a photo with this device, because I don't know. I have done it a long time ago, years ago, but I have no idea. So what do we do when we don't know how to do something? We look it up on Google. These days we can use AI, that is an option, but let's do the old-fashioned way. and look it up, the documentation. All right, so let's get our browser up and running. Let's put it here. Looks as good as any spot. All right, so we're going to look for ESP32 cam, and we want a sketch to take a photo. We got an AI result, but it links to a website. Let's click on the website. Let's make that a bit bigger. All right, so we're going to read through this documentation, see what the effort is. So looks like in this example, we are going to take a photo and display it in a web server. That should do the job for what we're trying to do. We don't want to do any of that stuff yet. I'm actually going to disconnect this because the noise is very annoying. Okay. Components, we don't need any of that. So we have a programmer board here. And what else do we have? Cables, jumper wires. We don't need jumper wires for our programming board. This is just going through what you're going to make. That's fine. We don't need to know any of that. We already know how to program it. We did it last time. So this is how you program it if you have a separate programmer board, not one that's like a hat that sits underneath. Okay, so we will need these libraries. So ESP async web server library, that'll be what we use to create a web server. Async TCP library, not sure why we need that. It's probably for some sort of communication between our front end and our website. Sorry, between our website and our ESP32 as the server. And that is not the ALPR server, that is something entirely different. So we're not going to touch the ALPR stuff just yet. We're just going to work out how to take photos. What do we got? Install the library, blah, blah, blah. All right, so what did we do last time? I think we used Arduino Cloud. And I believe we will do the same thing today. Yeah, if we're lucky, we'll just get some code that we can copy paste. That is a lot of code. All right, we'll go through this code because, well, we'll copy paste it first, and then we'll go through it line by line, just to make sure it does what we need it to do. Devices 0 online. Let's get you connected to the programming board. Give me 1 sec while I plug it in. So we need to unplug all of this. Get that out of the way. Okay, so let's plug this into the programmer board, like so, and then we'll plug in our data cable into our computer. Cool. See, that's powered up. We got a little light, and then hopefully this will pick up that we have a device. It's the one. Sure. To use this board, you need a device ID and a secret key. Why? Okay. Well, I swear we didn't have to do that last time. All right, let's have a look. What's going on here? So I'm just making sure we can see what's going on. All right, let's zoom out so I can have a look at what's going on. So we have our ESP32 thinker. It is currently offline. Huh. All right. Let's power it on. Let me do some magic somewhere else. Okay. I think this is for a Wi-Fi device. Let's delete that and start again. Add the device. Add your new device. You know, I remember last time we tested this, it just automatically came up. Oh, there it is. That's fine. We know what the device. Press the wrong button. Let's do that again. Arduino board, serial, that one. Change it. Did we use this last time? I thought we did. It is compatible. I don't know why I thought we weren't. Alright, cool. That's the device. Copy the code, throw it in there, save it. I'm going to assume that it's going to add these libraries automatically for me. Do we need to connect it to Wi-Fi? Yes, we will need to connect it to Wi-Fi. So I'll have to set up some credentials for that. I'm not going to show you my Wi-Fi credentials, but we'll get there. All right. Let's have a look at what we've got. So this sketch has a Wi-Fi. SPIFs is data storage. This FS will be file storage or something along those lines. String array, SP32. It's a bit overcomplicated. I reckon we can find a simpler sketch. I think this is overkill. Well, it's not that long. We'll give it a go. All right, so I'm going to turn my screen off and put in the Wi-Fi password. There we go. If I can remember what our Wi-Fi password is. All right, hopefully that works. Let's test it out. I've still got this little sticker on here. I should probably take it off. Okay, camera is now exposed. Okay, so that sketch is built. And now we are uploading it. While we're doing that, while it's doing that, let's have a look at what it does. So it's going to start a web server on port 80. We don't know what the IP address is of this thing. And I don't think I'm even connected to the same Wi-Fi network as this thing. So that'll be interesting. We'll get there. We'll see what happens. This is just some JavaScript. We could have done that a lot simpler, but that's fine. Did this have any code for MDNS? So MDNS lets you give your device a name. No, so it's going to log in the serial output the IP address. And that's what we have to try and connect to. Okay, so serial monitor. We've got the wrong forward speed. Go, so our IP address is that. Let's go to it. Ah, I just noticed the serial monitor didn't show up on the screen. All right, I need to switch Wi-Fi networks. I think that means I'll get disconnected. Let's find out. So I'll just try to configure my screen a little bit. Don't work. All right, delete that. All right, let's try that again. These devices can be slow, so I wouldn't be surprised if it doesn't work. I'm gonna go into my terminal and just curl. Let's just double check some of this code. So what does it do? It starts the serial monitor, connects to Wi-Fi. We are definitely connected to Wi-Fi. You can't see it, but I do have a screen open that says it connected to Wi-Fi. And I've got an IP address. And then it looks like it initiates the camera module. It's a lot of effort to initiate a camera. If there's any errors, I should get a log, which I didn't get. And then it's going to start the web server. So if I go to the root level, it's going to serve our HTML file. So it should work. It doesn't look like it does work. All right, let's go to plan B. Let's just try and get a web server running on this thing and connect it to Wi-Fi. Okay, so ESP32. Quick web server and connect to Wi-Fi. Looks good to me. Again, I will turn off my screen while I put in a password. And let's upload that again. Yeah, things don't always work first go. So, just perseverance, patience, these are things we need. Okay, still uploading. Oops, there we go, you saw my password. Wi-Fi. Let's check the serial monitor. Okay, again, it gave me the same IP address. Let's see if it actually works this time. If you can't see, there's a little spinny indicator saying it's doing stuff. But it could just be really slow, or it could not be working. I'm on a separate network, Wi-Fi network, so that could be part of the problem. Could be that this Wi-Fi antenna is just terrible. Yeah, we'll see. Most boring stream ever. Alright, I'm going to switch Wi-Fi networks, which means I'll probably get disconnected again. See if I get better luck on the same Wi-Fi network. Wi-Fi. So the problem was I was on a different Wi-Fi network, and so it wasn't connecting to the device. But we can see right here, we are connected. So let's go back to this thingy, copy some code, and try again. I already exposed my Wi-Fi password, so at least it's on a guest network, which I can just change later. Oh, what's going on? My sketch has disappeared. That's our servo sketch. We don't want that one. This is our Wi-Fi one. Let's call this Wi-Fi and camera. This is forgotten who it is. Upload and try again. All right. Oh, that's not good. Let's see. It lost a connection to my thing. Port doesn't exist. Well, it must exist because it says it exists right there. Try again. I don't think these things are guaranteed to work every time. I do find that if you have a bad data cable, USB cable, things tend to fail more often. Sometimes it's dependent on the device itself, which is this device is what I'm talking about. These are cheap. I think this thing is about $5, so it's pretty affordable, but also not guaranteed to work. Okay, so same error, port doesn't exist. So what we're going to do is disconnect it and plug it back in. And we are going to detach this thing and connect it up again. I should double check that it shows up in my system. So I'll do that. It does show up my system. That's good. Let's try and upload again. Anyway, so once this is running, we'll have a web. If what I glanced at the example correctly, it will bring up a web server. It'll allow you to take a photo, and then you'll get that photo uploaded to that web server and displayed to you. And so from that, we'll look at this sketch and we'll look at what does it take to take a photo, what does it take to receive a photo from somewhere, and then we will change that for our own use to send it to a different server. That's the plan, at least. I don't think we'll get there tonight, but we'll see. Okay, so that's loaded. So that will be connecting to Wi-Fi now, and it's up and running already. So let's press capture photo, see if that does anything. Capture photo, nothing. Any errors? Yes. What do we got? There's an error. Oh, hang on. It did in fact take a photo. All right. Cool, I guess. Maybe I should point it out myself. Capture photo. Looks like there's something dodgy with this code. I am just refreshing the page. There's no feedback on this screen. I guess I shouldn't expect the best website, but it'd be nice if I think it's actually designed to be bad. Okay. So it doesn't look like this capture button does something every time. Let's have a look at this network request and see what happens when we press this button. We can see that a network request is made. It's a GET request called capture, and a GET request has no body, nothing will happen, and it just returns the little web server. Okay, so if we go to, oh, okay, it finally worked. There's my beautiful head. Okay, so it does work. It's very slow, very flaky, but it does work. So we can take a photo. Let's work out how this thing works. Let's get rid of that. Let's make this code a bit bigger. All right. We don't need to see any of this. This is just the HTML for the website. We don't need to see any of this. This is just how to get the camera initiated. We do want to have a look at this. So we did see when we pressed the button, it hit this capture endpoint. It's a GET request. And let's have a look at what it does. All it does is set this boolean to new photo. So based on that, presumably they're in the microcontroller's loop. It's going to check for this new photo. If it's true, it's going to try and take a photo and then save it to spiffs. And when we refresh this page here, it will load that photo from spiffs. So let's have a look. So this starts the web server, and with our microcontrollers, we have a loop. This runs, I don't know, thousands of times a second. As I said, it checks this boolean that says if there's a new photo, do something. In this case, there's a function called capture save photo. Some odd naming convention, but that's fine. So it's gonna try and take a photo, and then it's gonna say flag that as new photo, no, false. Right, so let's find this capture save photo. Here we go. Don't know what this is. Don't know what this is. We won't worry about it for now. It should make sense as we move along. So we can see that it's logging that it's going to try to take a photo. So there's a ESP camera FB get. FB, what could FB mean? I don't know. That's why it's important to give your file, your variables, good names, so you know what that is. But we could look up the documentation, which we might do actually. We want the docs. We can stick to the ARE. So FB gets the camera hardware, signals the camera hardware to capture a new image, reserves a frame in buffer memory, and returns a pointer. Okay, so it's a pointer to the buffer data. I think that lines up with what we read. Yeah, there we go. It's a pointer to the camera, the image data. To the image data, to the buffer data. Takes 2 to 5 milliseconds to execute. After processing or saving the image, you must call ESP FB camera return to free the memory. Cool, we can do that. Okay, so we have our buffer data there. If there's no buffer data, it failed to take a photo and just exits. It's not going to retry because we set new photo to false here. If we didn't do that, it would try again on the next loop. Let's see. So SPIFs is a file system on ESP32 devices. So we can create a file path. So it creates a file. There's nothing in it yet. And then, so if there's no file, it fails to write. So there was a problem with SPIFs. Otherwise, we will save that buffer data, we get the buffer length, and we save it to that file. And then that'll be our image file. Presumably it's a JPEG, but we will see if we can do more, look at more into that later. So next thing we do is we close that file because it's open, and then we release the memory on the camera. And then we call a function called checkPhoto on SPIFs, and then if that's, and we do that over and over again until it succeeds. But if the camera fails, it won't try again because we have this return. And I think that's it. Any other scenario. So if anything happens with this file system, it'll keep trying again. If I try again, it'll try and take another photo. Okay, cool. Let's see what checkPhoto does. I'm assuming it just checks that it exists. Yeah, it just checks that it exists. And it's greater than 100. Don't know why they chose 100, what that means. I would have just picked greater than 0, but that's fine. Okay, so that's how it works. So that's how we get a file, an image, and that's how we save it onto the device. Presumably, that photo should still be on here. So I'm going to just, let me temporarily show this. I am going to disconnect this, and now it's got no power. And I believe SPIFs is saved to the device, like it doesn't disappear. So if I plug this back in again and then go back to this web server once it starts up again, that image should still be on there. And yes, that image is still on there, which is interesting. It means we always get that last image saved to the device. We don't actually need it for our purpose, but it's probably handy for something. So I think we'll go with that. Okay, so I want to take some notes just on how this thing works, and just so I don't forget when we actually do some programming. What are we going to do? Let's bring up this browser back. No, we'll stick to our notes. All right, so we don't need a web server. Let me point that out. We don't actually need a web server. That is just for testing. We only needed that to make sure that the camera was working. There are some benefits to spinning up a web server in that we can double check that things are working. We can, if we were positioning our camera, we may want to know that we put it in the right spot. So there might be a good reason to have that web server. But every line of code that you put into this device, these devices are quite limited. There's only so much code you can put into them. So we want to be selective about what code actually makes it into the device. We should be able to do a web server on top of whatever else we're doing, because what we're doing is really basic. And before we do that, let me just take some notes and what we need to do for this camera. So in our setup, that's a function. So in our setup function, we need to connect to Wi-Fi, of course. And in our actual demo, we're going to connect to a Starlink Wi-Fi hotspot. We need to initialize SPIFs. So we have somewhere to save our images. And we need to init the camera. In this case, we are not going to start a web server, so we're going to ignore all the code related to web servers. And then the next thing we have is our loop. And I guess this is the meat of what we want to do. So remember, this loop runs thousands of times a second, and we don't want to take a photo thousands of times a second. The act of taking the photo and saving it to disk will slow that process down. It'll never run more than once at a time. And so we can take advantage of that, which it just sort of means we don't need to worry that it's going to do it 1,000 times a second. But we do want to limit the speed because we don't want to be slamming our ALPR server with photos non-stop if we don't need to. So I'm thinking we take a photo every 5 seconds. So let's do that. So the way we can do that, we've got two ways of doing something every 5 seconds. One is you can put a delay in, and a delay will basically stop any execution. And then the other way is we can let it execute 1,000 times a second and just track when we last had our when we last measured what 5 seconds ago was. And we do that with, I think it's called, oh, it's been a long time. Something to do, it's like milliseconds, millis, maybe it's millis. Let me just Google that. Millis. Yes, it is millis. Okay, so millis will get you the time. So let's call this pause execution. And millis will just get you the execution. I'm not sure if this is the right name. Execution time. So it's kind of like a clock. So starting from 0, it increments in, I don't know, milliseconds. Yeah. So the reason you would want to that I would choose one or the other, I don't know which one's better, is if I go millis, I know it's executing every 5 seconds. With delay, if I say delay 5 seconds, it will delay for 5 seconds, but however long it takes for the camera to execute the code, that's on top. So it could be 5 seconds and it could be 5.5 seconds. So it really depends on the circumstance. Do you need something that is timed exactly every 5 seconds, or do you need something that just has a pause for 5 seconds and then whatever the execution time is fine? I personally never use delay if I can avoid it, because I usually have a lot of things running with different timers. But in this case, I think delay is the correct choice. So we'll go with delay. Put a tick on there. Just because the timing isn't really that important, it's just that it occurs occasionally. And the thing that I should probably actually talk about what we're actually doing. Basically, every 5 seconds, we want to take a photo, and we want to send it to our ALPR server. So we'll go on to the next step, which is take a photo. In this case, in our test code, it saves it to SPIFs. We don't need to. We have the buffer data. We can send that straight to the ALPR web server. I would have to think about whether there is any benefit to saving it to SPIFs. So one benefit is you can see the last image that it was taken. If you lose power, your device powers back up. It can resend that photo. I don't think we'd want that. So I think what we'll do is we will not save it to SPIFs. So let's get rid of SPIFs. Unless we need to, unless it makes it easier for us to send it to the API server, the ALPR server, we won't use SPIFs. There's just an extra thing that we don't need to do. So we take a photo, we send to, we'll do that. it's going to be a REST API server. So we just call it send to API, just for simplicity's sake. And the next thing is that's going to take some certain amount of time to execute. It's a pretty low resolution image. This little guy. So it's probably going to be, the detection is probably going to be super quick. I'm going to be running the ALPR server, at least for this demo, just on my laptop, which is a M5 Mac. So it's going to be super fast. And so the next thing we do is we wait for a response. Wait for the response. Okay, and then what do we do with that response? I don't really know. I know what it is going to be later. Later on, this API that we send it to isn't going to be the ALPR server. It will be our server that handles all of our parking system stuff, and that will be the one that sends it to the ALPR server. But for now, I think what we'll just do is we'll log the result. Sorry about my terrible handwriting. So we'll log the result, and so we'll get a couple of things. We'll get a lot of things actually, but the things we care about is the rego itself and maybe the confidence level if my server provides that. And that's sort of just how confident it is that it got it right. And so we'll log that to the serial monitor. Okay. Yeah, let's do it. I don't have my AOPR server running at the moment, but that's fine. We can make that work. Alright, so we're going to work in this web code editor, which does make it a bit tricky. I don't know which of these libraries we actually need to make this thing work, but we don't need a web server. Maybe we should use a web server. No, let's delete it for now. We don't need an image. This is our camera pins, which there is a lot of them. We don't need HTML because we don't have a web server. We do want serial begin because that's what we're going to log to. We do want to connect to Wi-Fi. That's fine. We don't need spiffs, so let's get rid of it. We do want to know our IP address. I would like to use MSDN Wi-Fi. And that'll just give us a name instead of an IP address. So what do we need? We need ESP MDNS. Let's throw that in there somewhere. And we need to give it a name. Let's call it parking. This will be accessible from parking.local. And then we connect to Wi-Fi. And then we start MDNS. So let's do that. So we connect to Wi-Fi, and we'll start our MDNS. Don't know what this brownout detector is. We'll leave it in there since I don't know what it is. This is all configuration for the camera. That stays. If the camera is not okay, it restarts. That's fine. We don't need anything related to the web server. So let's delete all that. We don't need any of this code. We don't need to check the photo. We do want to capture a photo. Capture photo and return. Let's break it up into two separate fractions. We want capture photo and return buffer. And then we want another function which is send image buffer to API server. Yeah, it's a bit wordy, but that's fine. And there to do. We'll leave this in here. Yep. All right. I'm going to pass this off to AI to just implement some of the stuff that I don't want to implement. Just give me 1 second. Shouldn't take long. So I'm just going to ask AI clean up this code and tell it what it's meant to do, which is take a photo every 5 seconds and send it to my API server and send the image buffer to my API server. Hopefully it gives me a placeholder for my the IP address of my server. While it's doing that, you know what? I might check to see if my license plate recognition server is running or can be run. Let's see, where did I put it? It's running at the moment. AI is still checking the code. Give it some time. Let's see, is stuff running? So my ALPR server. Let me. Got a fake API key, which is good. Let me pass this to AI. Let's see. I'm fairly certain it takes a buffer. I think it might be a base 64 buffer. So the knowing me, I did create documentation for my own server, so let me just check that. It does, okay. It can take a base 64 image. It can take an image URL. So if I publish it online, I can give it a URL. I think we'll go base 64 encoded buffer. So give me 1 second. And all right, so I'm just making some changes to that code using AI. I gave it my documentation on how it needs to send the image to my server. Doesn't know my IP address. I don't know my IP address. Give me 1 second. Let's find out what it is. My IP address is. Found it. Okay. All right, let's have a look at our new code. So AI made this. It cleaned up all my includes. Oh, this is the same. This is my web server. It's not HTTPS. It is that. That's it. This is our API. I've got a fake API key I can use. Oh, where is it? Something like dead beef. Dead beef, dead beef. Okay. So it's an API key for our API server. We provide a region, so we say what country is this license plate from, and that will help us with our detection. How many API results we want? 5, whatever, good enough. How often we want a photo taken? Good. When it was last captured? Good. Init camera loop. Okay, cool. So this checks to make sure our Wi-Fi is connected, because if it's not connected, there's no point in doing anything. And it will try and connect to Wi-Fi. This is going to use millis, so AI decided millis was the better option. It's probably because the instruction I gave it was to take it every 5 seconds rather than just have a pause of 5 seconds. That's fine. That should still work. So we capture our photo and then we send it to our API server. So yeah, this was pretty easy. We get our buffer pointer, and that thing will get our pointer to our buffer and returns a pointer. Okay, good. So we take in a pointer. Hang on, this doesn't release the memory. That's probably fine. Checks the Wi-Fi again for some reason. Okay, so it converts our buffer data to base64. I assume that's a real library and it didn't just make that up, as AI does often. And our server requires it be structured in JSON. And this is the correct format. That's fine. Starts a HTTP client. Puts our API key in the X API header, tells it its application JSON, so tells it what it's sending, and then makes a post request. And if all goes well, it'll give us the payload. That payload is going to be gigantic, because we do provide a bit more than just the rego. But to see that stuff is working, that should be fine. All right, so let's connect this thing again. Let's upload this code. And let's test while we're here, let's what are my test credentials? Dev at example.com. Sure, you can remember that. Okay, so let's check to make sure this code uploads correctly. Code is uploading. So the way my API server works is every time you make an API request, it will update the history. So if it is working, it will see stuff. But I'm going to look up the serial monitor and just make sure it just check to see what it's doing. So it said it captured a photo and says it uploaded and failed with HTTP code 308. What is HTTP code 308? I don't know. That's not familiar with that one. Permanent redirect indicates request is permanently moved to the URL. Okay. That's so it definitely didn't make it through. Why would I get a 308? Let me check my docs. Docs. We call a post request to recognize. Yeah, it's pretty straightforward. You know what? I've got a test script. Might try that. Oh, you know what? I think I got the port wrong. Let's see. So, yep. 5173. And then the other thing is, does my web server run exposed? No, my web server is not exposed to other things on the network, so I do need to change my web test server. That's fine. We can do that. Oh, actually. No, maybe that's fine. Let's see how that goes. Let's put up the serial monitor. It says it's done. Okay. Nothing's been sent. My serial monitor is not working. No, it is. Okay, so device connected to Wi-Fi and DNS starts up. Good. Capturing photo. Upload failed. Bytecode. HTTP code -1. Well, that's annoying, isn't it? Let's go investigate with AI. I'm going to check my server logs and to see if I can see anything failing to execute. It is executing, yeah. To be fair, I haven't actually tested the base64 feature on my API server. I've just done image URLs. No errors or warnings on my server. It means connection refused if I get a -1. If you want to, you know what, let me make sure my log of what my error is. This is the error I'm getting when I try and upload a photo. And so that means that the connection was refused. That makes sense, I guess. That would be because my API server is not exposed to any other device on the network. Okay, cool. That's all right. We can fix that. Give me 1 second. What do we want? All right. So I'm just going to make, I'm not going to show you the code for this because it's not ready for the public. But what I'm going to do in the background is my API server, which is only running on my laptop at the moment, doesn't allow connections from other devices in the network. Like by default, we try and make things secure to begin with, and we only open things up as we need to. If I had this published on the internet, that wouldn't be an issue because, you know, it's published on the internet. Let's see, what have we got? What have I set up for? Yeah, so I'm going to make these changes, and then I'm going to restart my server, and then we'll go off from there. So this shouldn't take long, maybe a few minutes. Yeah, you know, I could have made this stream more exciting and made everything work first go, but these are the sort of issues you run into in the real world. Things don't always work first go, and you've got to make it work. Still building. We'll get there. Alright, so let's start that up and see what happens. If stuff is working, I should see it working straight away. Oh, there we go. We have success. Alright, so we are now getting this as a response. No detections, which is correct because there's no trucks. So what I'm going to do is look up a truck. Well, actually, let's look up Australian cars. I kind of want a real car. Yeah, that'll do. And what we'll do is we'll point our, that'll do. We'll point the camera at this car and we'll see if we get a detection. You know what? You won't be able to see if I get a detection or not. And I actually also don't know what orientation this camera should be in. Oh, maybe I've got it upside down. Okay, cool. We have success. So let's have a look. Let me show you what I got. This is what I got. So what you can see is how long it took to process that image that it took, which is 41 milliseconds, which is great. That's nice and speedy. It detected the plate 1YZ7WR. So 1YZ7WR. So we got it spot on. And if we look in here, we can see all the photos we took. And so when I actually got the orientation correct, this is the photo it took. It's very blurry, but it still correctly identified it. So let's get rid of that. We don't, well, let's keep, oh, you know what? Let's keep that there in case we need it for later. All right, so we got a confidence between 0 and 1, and it's so 0.965 means 96.5 confident that it's correct. Gives us the coordinates of the image that it used, which is good if you want to take a slice of that image and you just display just that license plate. Sometimes if there's multiple cars, what will happen is you'll get multiple plates back and each one will have its own confidence. You can see here that it actually detected the plate multiple times with different confidence ratings, and what we got was the one that had the highest confidence rating. So this one had IYZ7WR, which was incorrect, but it was still an 80% match. And so that's how it works. And that's it. So we now we have our license plate detection. We know it works. So we'll just leave these comments in here just so we know what happens when the can't connect to the API server. And this one will be a successful detection. And I'll just put one more, which is no detection. And the reason I'm just leaving these as comments in here is so we can reference it back later. So when we're writing some code that we actually want to do something with, I think we don't want to do anything with it, but it's just good to have a reference of what we're going to get from a real world example. So yeah, I don't know. How can I make this more interesting to demo? I am flooding my server with things. I wonder if we should throw these out. Because I only made this server recently just to test that this would work. So it's not fully fleshed out, but I think I might make it delete no detections. Or maybe, I don't know. Anyway, we know it works. So I think that's the end of this stream for now. Well, definitely the end of the stream. And I guess the next steps, what's the next stream going to be about? So we've got our Boomgate working. Well, we've got a motor working, and we've got our camera working, and we've got a license plate detection. So I think the next thing to do is once we get a successful detection, we'll make it so that a Boomgate opens. So I might, on our next stream, I might, or I will, or maybe I might, I'll get this little guy, this little motor, and we'll mount it to something, and we'll make it look like a Boomgate. We'll double check that it still works, the code still works. And then what we'll do is we will get this camera to, whenever it successfully detects a license plate, we'll make it open the Boomgate. And we'll actually put a delay in, enough to give enough time for this Boomgate to open, presumably let a car through, and then close, and then it'll continue taking photos again. And that'll prevent it from just opening and closing nonstop. Yeah, I think that's it. All right, that's the end of the stream. See you later.